Welcome back to Software Architecture and Distributed Programming. In this video series, we're going to be talking about JavaScript. So we're going to be making front-end applications. And in order to get started with front-end applications, what we need to be learning first is JavaScript. So don't we have enough languages already? We know some C#, we know some Java. You might also know some other languages. Why do we need another one? Well, we need another one because we're going to be making web applications, which means that we will have applications that run inside of browsers. And because they run inside of browsers, we either have to use what's called WebAssembly or we have to learn JavaScript. So what we have here is a web browser. Web browsers inherently understand JavaScript code. JavaScript is what we call an interpreted language. And what does that mean? Well, it means there exists an interpreter in order to interpret the language. So if I write some JavaScript code, this is just a simple hello world program in JavaScript, the browser will know what this is because the browser has what's called an engine. And the engine for this browser in particular is called V8. And V8 knows how to interpret this code. So, can you run JavaScript without a browser? Well, until 2009, the answer to that question was no. You cannot run JavaScript without a browser. But someone made a runtime back in 2009 that allowed us to write JavaScript code and execute it outside of browsers by making this runtime for V8. And that runtime is called Node.js. So if I write a simple program, I can just make a file that ends in JS. Let's call it example.js. And let's edit this file. And we can just write the same program in here, console.log, hello world, like this. Let's save this. And now we can write node example.js and we get hello world, just like inside of the browser. In order to get started with JavaScript and how we're going to be working with it, you need to have Node.js installed. And when you install Node.js, you automatically also install what's called the Node Package Manager. The other thing you will need is you will need some kind of a browser. It doesn't really matter which one. I use sometimes Firefox and sometimes I use Google Chrome. In order to figure out if you have correctly installed Node and you have the Node Package Manager, you can just write node and -v and it will tell you the version. And it's the same with the Node Package Manager. Notice how they are not the same versions, even though you might have installed them together. They have completely different versions. Starting out with JavaScript, we're just going to execute it using Node.js, which means we won't be making any graphical user interfaces in the beginning. So we like to just have some closed environment where we can run all the JavaScript code. And then once we're getting more comfortable with JavaScript, we're moving into the browser. My preferred IDE for making JavaScript applications is WebStorm. You can also use VS Code or any text editor that you want. It really doesn't matter. It's just important that you have a terminal and that you have something that you can edit code in. So I'm mostly going to be using terminal, and a lot of the tools that we're going to be using does not have any graphical user interface. So you are absolutely forced to be using a terminal. We're going to talk a little bit about what kind of files we're going to be working with when we do Node.js applications. So first off, there's of course all the JavaScript files. They end in .js, so we can just make one here, index.js, that's what we're going to call it. And you could of course also just make a file here by clicking file or clicking JavaScript file or whatever. It's just a little faster to use the terminal sometimes. And another file you're going to be looking a lot in is the one called package.json. But we don't actually write the package.json file ourselves. What we do is we use the CLI to create a file called package.json. So what we do as the first thing when we make a Node.js application is we write npm init, stands for initialize, and you will have some kind of installation wizard if you don't put the -y here. So we'll just do this, and then you get a file that looks like this. So there's some data about our application. There's what's called the entry point to the application, index.js. It's the one we just created here. And there's a name of the application, there's a version and a description and yada, yada, yada. And there are a couple things here that are very interesting for us. One is called scripts. So you could have a certain script for testing the application, one for running the application, one for building the application, and so on. And these scripts will be listed here. And once you start adding more dependencies into your application, you'll start to get more and more scripts. So it's very good to just take a look at what you have here sometimes. Another thing that you'll also be looking a lot at is your dependencies. Right now we don't have any dependencies, but we can install some. So we can install one called Express, for example. npm I express stands for Node Package Manager install Express. So there's a package called Express, and we're installing this using the Node Package Manager. If you remember working with NuGet Package Manager in C#, this is basically that, just with JavaScript. So if we take a look at our package.json file now, we'll see that we have this dependency, Express, and we're using version 4, and then the minor version 18, and then the patch version 1. And you'll also see that we have a new folder here called Node Modules. Node Modules is where we store all the build dependencies. So why do we need this? Well, we need this because when I execute something from the library we just installed, this is all the code that's actually executed. It's in here, and I didn't write this myself, of course. This is just something that is required for my application to run. You should always add this folder to your gitignore. So if we make a gitignore file, we can just write touch.gitignore, and we should have a gitignore file here. Gonna add node modules as the first thing. And once we have node modules added here, we know that this will never be pushed to GitHub, right? And we can delete this. It really doesn't matter because we can easily get it back by writing npm I, where I stands for install. And then once we run npm install, we'll get the node modules back. And why do we get the same dependencies built in here? Well, we get the same dependencies built in here every single time because they're listed inside of the dependencies here. Which means that if I install something new like npm bcrypt, it's something we use for encryption, you'll see that we now have even more dependencies in here. There's a whole bunch of stuff. And this project is already huge, but the thing is our source code is non-existent. We basically haven't written anything. These dependencies just exist because they are here. I could remove these like this, and if we did an npm install now and there wasn't any node modules, we wouldn't get this folder because there's basically nothing to build right now. When you install packages using Node Package Manager, you also get the decision to make it a global package or a locally installed package. So when we wrote npm I express, we're of course installing it in this directory, right? But let's say that there is something that we want to use globally on our machine. We can make a global installation. So for example, there is something called np executable. So those are just programs we can run using the Node Package Manager. And we might want to run these executables anywhere on our machine. So we can just install the package globally. This is how it would look like. npm I, a little dash and a G, and then the package name. So there's something called npkill. And we can install that one. And because this is a Linux machine, I have to write sudo when I do something like this. And now I get to use the npkill package globally anywhere on the machine. So I could write sudo npkill. And what this package does is that it deletes node modules for me. So right now I have a node module folder and it's taking up 2.27 megabytes, and now it's deleted. So I can use that program anywhere on my computer now because it's globally installed on my machine, whereas the things that I installed under dependencies here, they are only accessible inside of this directory. And right now we just deleted the node modules, so WebStorm will let us know that we haven't installed our dependencies. So it's really nice and saying, do you want to run this? And we say, yeah, let's run it. In JavaScript, we have different ways of declaring variables. So first of all, we have the keyword const. And the keyword const refers to something that is not reassignable. So of course, we would use it for constants. And then we have something called let, which is reassignable. And right now, this makes perfect sense, something that is not reassignable and something that is reassignable. And then we have a third keyword called var. And var is funny because var means that we have something that is accessible outside of the scope that it's declared in. And let is not accessible outside of its scope. So when should you use which one? Well, the short answer is never use var. IDEs nowadays will even let you know if you used var, and then it'll let you know that you can convert it to something else, because var is considered to be a bad practice to use. So the short answer is don't use var. Use const and use let. For most programs, it really doesn't matter if they write let or var. They will run just perfectly fine even with var. But it's seen as a good practice to use let instead of var. Just ask yourself, do I want to reassign or not? If the answer is I don't want to reassign, you use const. And if the answer is yes, I might want to reassign at some point, use let. One thing that's very different in JavaScript compared to many other languages is we have what's called strictly equals and loosely equals. And let me show you something that might seem a little crazy. So let's make some statements here. Let's say let k equals 10. Let I equals string containing 10. And now I'm going to write console.log 10 k and I. So this seems like a weird thing to do. Like, why would you compare this number to this string? Well, let's see what it actually outputs here. So we're going to write node index.js, and we'll see the value true here, which means that JavaScript says that this is equal to this. That's crazy, right? We all know that a number and something that is a sequence of characters, like a string, they're not the same thing. Well, if we add another equals here, we have what's called strictly equals. And now JavaScript says that this is false. So there is a difference between something that has 3 equal signs and something that only has 2 equal signs. The reason why that they are loosely equals but not strictly equals is that the loosely equals operation doesn't care about the type. It finds what's called a common type and then it compares. So when should you use strictly equals and when should you use loosely equals? So a lot of people will tell you never use loosely equals, because what if you accidentally get something that is a true statement and it's something like this? So the easy answer is just always use strictly equals. But sometimes there are multiple things you want to check for. We have something called null and something called undefined in JavaScript. So null, we know what that is. And then there's this new thing called undefined. And typically, when you want to check if something is null, you also want to check if it happens to be undefined. And therefore, instead of saying null or undefined, you could just say loosely equals undefined, because this statement here is a true statement that null and undefined are loosely equals each other. Just know that there is a difference between 2 equals and 3 equals. We're going to talk about functions in JavaScript. So if we start off by just writing a simple class here, class, my class, curly brackets, and let's make a function here. That's it. This is a valid function inside of JavaScript. We don't have to write return statements. We don't really have to write a whole bunch of stuff. If we delete the class here, we'll start to get a problem, because now it says we don't know what this is. If it's inside of a class, we know this is a function, but outside of a class, we have to write function and then the name. So there are other ways in which we can write functions inside of JavaScript. So I'm going to show you another way here. Const a equals empty parentheses arrow scope. And here we can write a return statement. Return hello world. Let's use this one. Console.log a like this. Node index.js. Hello world. So this is a perfectly valid function. And we can also give it an input. Let's say what to write. Return what to write. Blah blah. One of the inherent limitations that exist with JavaScript is that it doesn't support types out of the box, which means that if I like to specify that this function returns a string, that's not allowed. So what do we go from here? Well, what we do is we're going to use what's called Typescript. So Typescript is built on top of JavaScript. And what Typescript does is it helps us figure out a lot of the limitations our code has before we get to execution time. So even at compile time, we see a lot of the problems that we might have encountered during runtime with normal JavaScript. So Typescript has support for types, which means if I go into this file and I rename it TS, which is the file extension for Typescript, we see that now this is completely valid. It wasn't valid before. And what I say here is the function A should return a string. So if I say number instead, so number is a perfectly valid type inside of Typescript, we'll get this error here because we're not returning a number right. So now we can be more specific with our code. And how we would execute this is we would just write ts-node and then the file we want to execute. Like this is index.ts now. And now we get a hello world. Well, of course, we're not console.log in this one. We can just write console.log a like this. And now we get the hello world. So generally speaking, a lot of frameworks in 2022 and beyond will be using TypeScript rather than JavaScript because it is inherently more scalable. There is nothing wrong with using JavaScript as it is. The thing about JavaScript is that the browser still only understands JavaScript. So the TypeScript code is actually being converted into JavaScript. So your program will still be a JavaScript program, but the source code that you write is TypeScript.